Hello everyone, I am Manupriya DA from Sri Venkateshwara College of Engineering from Data Science Department. Today the course that I am gonna speak about is ADA, and the topic for today is minimum spanning tree. Basically, a minimum spanning tree, it is a way to connect all the points in a network like cities or computer nodes using the shortest possible total distance or cost. Imagine you want to build roads to connect several cities and you want to use the least amount of road to connect them all without creating any loops. For this, the minimum spanning tree helps you to figure out the most efficient way to do this. It ensures that every city is reachable from any other city with the minimum length of roads. Algorithms like Kruskal's and Prim's helps in finding these optimal connections effectively. Kruskal's minimum spanning tree. First, mainly what is Kruskal's minimum spanning tree? It sorts all the edges in non-decreasing order of their weight. Secondly, it picks the smallest edge and it checks if it forms a cycle with the spanning tree formed so far. If a cycle is not formed, then you include the edge, else you will discard it. Thirdly, repeat until there are edges in the spanning tree, that is v minus 1 edges in the spanning tree. And one more thing, why this spanning tree is called minimum? It's called minimum spanning tree because the weight of the edge, the total weight of the edge is very less. That is, it's minimum. That's why it is called minimum spanning tree. Let's take an example and see this. This is the graph. This is the graph which I want to explain. Like, let's explain this graph. I'll explain this graph using Kruskal's algorithm. Okay, coming to first step, you write all the vertices. This is the graph, and you write all the vertices, that is B, C, D, E, F, G. These are the vertices. First step is you write all the vertices. And the second step. In the second step, you need to find out the minimum number to connect a node. So minimum number in the sense, first minimum is 1. So you connect B to D and name as 1. And next number, minimum number is F to G, and you connect F to G and the number is 1. After 1, you connect what is the next smallest number in the graph. You need to see the next smallest number in the graph. So next smallest number is 2. There are two 2's over here, like one is connected from A to B. So let's connect from A to B and that becomes 2, and D to E, that becomes 2. This is the third step. Next step. Next you need to see the next least number, that is 3. 3, if you add 3 here, like if you add 3 here, you can't add 3 here. Is it possible? No, because if you add 3 here, it becomes a cycle. In this minimum spanning tree, the major important thing is this uh, vertices should not form a cycle. If it is forming a cycle, then you need to discard that node. So we'll not consider 3. The next step is the minimum value is 4. Here 4, there are two 4's. A to D is also 4 and B to G is also 4. Now if you join this A to D, you can't join A to D because it forms a cycle. It can't be formed because it forms a cycle. So this will be discarded. But you can join this B to G as it does not forms a cycle. So you will discard this one here. Next minimum number is 5. A to F is 5. If you again, you can't join A to F, because if you join A to F again it forms a cycle. So even 5 is discarded. Next comes 6. You join G to C and name it as 6. Next 7. B to C is 7, but you can't join connect the both the nodes, because again it forms a cycle. So now all the now all the vertices are being connected. After connecting, you stop the process. Now as you can see, all the vertices are connected to a node, forming no cycles. Now you stop now. And how do you calculate the total weight of the graph? Total weight of the graph you calculate it by 6 plus 4 plus 2 plus 2 plus 1 plus 1. So the total weight you add, and the total weight of this graph is 16. This is how you calculate the total weight of the graph. Now as we see, I've seen the example for Kruskal's algorithm. Let me tell you the applications of this Kruskal's algorithm. This Kruskal's algorithm is often used to design efficient communication networks such as cable TV or internet infrastructure. Like in a network design, like you can connect with various internet cables without having a single node or something. And it can also be used in apply to the layout of electronic circuits, minimizing the total length of the interconnections. Instead of interconnecting all the wires, using this application, that is Kruskal's algorithm, you can minimize the total length of the connection. Then the transportation planning, as I said earlier, it is useful for transportation network like roads or airline routes, and it is very minimum cost. Coming to end, this provides more efficiency. This Kruskal's algorithm is a highly efficient way to construct the minimum spanning tree with a time complexity of 0 E of log E. Versatility, the algorithm can be applied to wide range of problems from network design to transportation planning, making it a versatile tool. Simplicity, the step-by-step nature of Kruskal's algorithm along with its use of well-known data structures make it relatively easy to access and understand and implement. By combining these key strengths, Kruskal's algorithm has become a fundamental field of graph theory and optimization, making it an essential tool for solving many problems. Thank you.